Dear students, in the previous lecture, we have derived an expression to determine the total pressure and position of center of pressure on a plane vertical surface. So now we will try to solve a numerical related to a vertical plane surface. So here we have a rectangular plane surface which is 2 meter wide and 3 meter deep. And we need to determine the total pressure F and position of center of pressure on this vertical plane surface when it is held with its upper edge horizontal and coincides with the water surface, and it is 2.5 meter below the water surface. We have two different cases. Consider the first case. We will draw the water surface. It is said that the plane surface coincides with the free water surface. So this side will be 2 meter, this side will be 3 meter. We know that the total pressure is given by rho G A H bar, and position of center of pressure is given by Ig by AH bar plus H bar. We know that density, since it is immersed in water, density is 1000 kg per meter cube. Area of the rectangular surface is 2 into 3, that is 6 meter square. And H bar is the position of centroid of the area from the free surface. Since it is a rectangular surface, we can mark the centroid here. This indicates H bar, the vertical distance from the free surface to the centroid. So it is clear that H bar is equal to 3 by 2, that is 1.5 meter. Now we will substitute in our equation. F is equal to 1000 into 9.81 into 6 into 1.5, and we will get it as 88290 Newton. Total pressure is the force acting on the rectangular plane surface. So the unit will be Newton. Now we need to determine the position of center of pressure. For that, we should know Ig, that is moment of inertia. We know that for a rectangular plane surface, the moment of inertia is given by 1 by 12 into BDQ, which will be 1 by 12 into B is 2 and D is 3. We will get it as 4.5 meter raised to 4. Now we will substitute in our expression. H star is equal to Ig divided by A H bar plus H bar. We will get it as 2 meters. So we can mark it here. P denotes center of pressure. So this distance will be 2 meter and H bar is 1.5 meter. P will be always below. Now we will consider the second case. So here the vertical plane surface is held 2.5 meter below the free water surface. So the upper edge will be at a depth of 2.5 meter from the free water surface. This side is 2 meter and this side is 3 meter. So here we will mark the centroid. Now this distance will be our H bar. So H bar will be equal to 2.5 plus 3 by 2, and we will get it as 1000 into 9.81 into 6 into 4. We will get it as 235440 Newton. Now H star will be equal to Ig. Ig is 4.5 meter. Moment of inertia is measured about an axis which is parallel to the free surface. This is the axis considered to determine the moment of inertia, and this axis should be parallel to the free surface. So Ig is 1 by 12 into BDQ. So we will get the same value 4.5 divided by area is 6, h bar is 4 plus 4, we'll get it as 4.1875 meters.